So today I will discuss lecture 2, chemical bonding, VSEPR theory. Okay, so VSEPR theory is given by Sedgwick and Pauli. Okay, so basically from this theory we just know that to explain shape and geometry of the molecule and based on electronic repulsion of electron pairs is valency in valency. Okay, so basically these two things we are known from this theory. Okay, so from the first postulate is Bezier theory. Geometry and shape of a molecule is decided by number of pairs, that is lone pair plus bond pair in valency. Okay, so at first we have to consider what is the repulsion, that is repulsion between lone pair is greater than lone pair bond pair is greater than bond pair repulsion. Okay, basically why the lone pair repulsion is greater. So, lone pair are influenced by only nuclear attraction of central atom, so it is very much higher. Okay, next a bond pair of electron are influenced by nuclear attraction of central atom and side atom. Okay, so this will be less. Next second postulate is lone pair and bond pair tends to occupy such a position that minimize electron repulsion and maximum distance between them. Double bond occupy more space around central atom. Okay, so here double bond is greater, then double bond, then single bond. Okay, so basically from these two postulate we can consider that lone pair is repulsion is greater, and then lone pair and bond pairs tends to occupy such that minimum repulsion are there. Okay, next representation, how we can represent a molecule. Okay, so basically the formula is ABMLN. Okay, so from this representation we can all structure of the molecules draw. So you can see it ABMLN. Okay, A is the central atom, B is the sided atom. Okay, L is lone pair and small m is number of sided atom and n is equal to number of lone pair. Okay, so this is the representation. I can draw all structure from this representation. Okay, so note at first you have to note this three because it is a very important concept from this chapter, that is steric number. What is steric number? Steric number is the summation over number of bond pair plus number of lone pairs. Okay, next geometry of a molecule is decided by steric number and shape is obtained by arrangement of lone pair is in geometry, and if lone pair is absent then geometry and shape of the molecule are same. Okay, basically three things are very important for exam point of view. You remember these three things. Okay, so at first representation, from this representation I can first representation is AB2L0 type, that is here lone pair is 0. Okay, lone pair is 0 and steric number, so A is central atom, B is sided atom. Okay, so steric number is equal to 2 plus 0, that is 2. If steric number is 2 then geometry is linear. Okay, and as there is no lone pair, so shape and geometry is same, so shape is also linear and bond angle here 180 degree. So the representation of linear molecule, that is BAB. Okay, and the example of this type of molecule are BeCl2, BeH2, HgCl2, CO2, etc. Okay, next the representation is AB3L0. Okay, here also lone pair is 0, so steric number is only bond pair, so here B atom is 3, so bond pair is 3, steric number is 3, so geometry and shape is same, and geometry is trigonal planar and shape also trigonal planar. Okay, so here bond angle is 120 degree and this is the structure of AB3 molecule, and the examples are BF3, BCl3, AlCl3, CO3 2-. Okay, these are the examples. Next representation is AB2L1, that is lone pair here 1. Okay, so steric number is also 2 plus 1, that is 3, and so here geometry and shape are different, because here one lone pair is there, so geometry is trigonal or planar, but in shape is bent or V shape. This is the structure of AB2L1 molecule. Okay, so here the examples of AB2L1 molecule are SO2, SCO2, SnCl2. Okay, and the representation of a lone pair in this molecule is in this here. Okay, because if there are this lone pair is here, then minimum repulsion are there, and bond angle is 119.5 degree. Next representation, AB4L0 type. Okay, here lone pair is 0, so steric number 4 plus 0 is equal to 4, and geometry and shape is same because lone pair is 0, so geometry and shape are tetrahedral, and bond angle is 109.28 minute. Okay, so here example are methane, ammonium, and CCl4, SiCl4. Okay, this is tetrahedral molecule, and bond angle is 109.28 minute. Okay, next case 1 from this tetrahedral geometry. Okay, AB3L1, that is here lone pair is 1, so steric number 3 plus 1, that is 4. Geometry here tetrahedral, but shape is different, that is pyramidal, because here one lone pair is there. Okay, in shape the lone pair is not considered, so bond angle is 107 degree, and here the molecules that are example as an example, that is ammonia, pH3 and H3O plus. Next example from tetrahedral geometry, that is AB2L2. Here lone pair is 2, so steric number also 2 plus 2, that is 4. Geometry is tetrahedral, but shape is different because here 2 lone pairs are there, so shape is V shape. Okay, bond angle is 104.5 degree. It is that is common example, water. Okay, next H2S Cl2O, that is. Okay, next molecule is AB5L0 type, that is lone pair 0. Okay, steric number 5 plus 0, that is 5. Geometry is trigonal bipyramidal, and shape is also trigonal bipyramidal because here lone pair is 0, so geometry and shape are same. Bond angle, three types of angle are there, that is 120 degree, 90 degree and 180 degree. Okay, so because this is the trigonal planar formation. Okay, and one bond is upper side and one bond is lower side. Okay, so these three trigonal planar the structure, here 3 bonds are 120 degree, but from this and this are 90 degree, and B these are 180 degree. Okay, so this is trigonal bipyramidal. This is very important in your exam point of view. This type of questions are asked. Next, AB4L1 type. This is very important for NEET, JAM, etc. Okay, so lone pair is equal to here 1. Steric number 4 plus 1, that is 5. Geometry is trigonal bipyramidal, also the same because that is AB4L1 molecule, and but shape is different, that is seesaw structure. Okay, example SF4, it is very important. Okay, next case 2, that is AB3L2 type. Here lone pair is 2, steric number 3 plus 2, that is 5. Geometry is trigonal bipyramidal, but shape is T shape because 2 lone pair are there. Okay, examples are ClF3, ICl3, XeOF2, etc. Next case 3, AB2L3 molecule, that is lone pair 3, steric number 5. Okay, 2 plus 3, that is 5. Geometry is trigonal bipyramidal, but shape is linear because 3 lone pair are there. Okay, next examples are XeF2, ICl2, I3 minus. Okay, this is also very important. Next AB6L0 type, that is here lone pair is 0, steric number 6 plus 0 is equal to 6. Geometry is equal to octahedral. Steric number 6, geometry octahedral, but shape is square bipyramidal or octahedral. Okay, bond angle are 90 degree, and example SF6, TeCl6, XeO2, F4, etc. Okay, next From this geometry, there are two cases. That is, one is AB5 L1 type. Here lone pair is 1. So static number is equal to 5 plus 1, that is 6, and geometry is equal to octahedral. Okay, but shape is different because one lone pair is there. So square, this is the shape of square pyramidal. Example are very important. XCOF4, that is very often asked in the exam. RCL5, BRF5. Okay, so I can draw one structure, that is XCOF4. This is the structure. Okay, next AB4 L2 type. Okay, here lone pair is 2, so static number 4 plus 2, that is 6. Geometry is octahedral, but shape is different because there are two lone pairs, so square planar. This is structure of square planar. Okay, example are XCF4, ICL4 minus, TECL4 2 minus, SBCL4 3 minus. Okay, next AB7L0 type, that is a lone pair is equal to 0, static number 7 plus 0 is equal to 7, geometry is equal to pentagonal bipyramidal, but shape is also pentagonal bipyramidal because lone pair is 0, and bond angle is, there are two types of bond angles, that is 72 degree and 90 degree, and here one example is there, that is IF7. It is also very very important question. Okay, the example is this. Next AB6L1. Okay, here lone pair is 1, so static number 6 plus 1, that is 7. Geometry is also same, that is pentagonal bipyramidal, but shape is different because here one lone pair is there. So this is distorted octahedral geometry. Okay, example are XCF6, ICL6 minus. Okay, next AB5L2 type. Here lone pair is 2, so static number 5 plus 2, that is 7. Geometry also are same because pentagonal bipyramidal this is. Okay, but shape is different because here two lone pair are there, so pentagonal planar is the structure. Okay, and example is XCF5 minus. Okay, so these are all types of structure you can remember, but if you read when hybridization concept, then you will get this molecule easily. You can draw this molecule easily. Okay, but this is not in your syllabus, so I will not explain this. Okay, you can if you can read from books, you can easily this type of molecules you can easily draw the structure. Okay, so basically these are very important concept, and from this topic every and each exam from this topic question are asked. Okay, basically from linear molecule, TBP molecule. Okay, and that is seesaw structure. Okay, and that is T shape, linear shape. Okay, these are very important in exam point of view. So thank you, and if the video is helpful for you, please do comment and like from this video. Okay.